I have an unfed half-wave antenna bought from a local ham with a 49:1 balance at feed point and meant for 40, 20, 15 and 10 meter bands. So far, I have not been able to put it to great use due to various local constraints in mounting it at a good height and orientation. Though it is possible to mount it according to the manufacturer in any fashion like horizontal, inverted V, sloper and zigzag, many of my friends told me that horizontal mounting at a half wavelength height would give best results. That means I have to keep it at 20 meter height from the ground, which is impossible in my situation. I've been trying mostly zigzag mounting in multiple orientations with not very satisfactory results so far. My 40-10 meter combination inverted V dipole antenna with a 1:1 balance is currently working fine on 40 meter. It used to work well on 10 meter till the band became almost dead in the summer doldrums. As I do not want to disturb that antenna, which occupies the best position and mounting on my terrace, I have to go for compromised mounting for my EFHW with suboptimal results. Started reading a bit more on EFHW and found that mounting the antenna closer to the ground results in more signals being absorbed by the ground and the remaining signals being reflected skyward, sometimes called as cloud burner antenna. Though my 20 meter long EFHW will resonate at all harmonics, the radiation pattern will be different on each of the bands according to antenna modeling charts. While the fundamental frequency will have a single lobe of radiation, second harmonic can have 2 lobes and third harmonic 3 lobes of radiation. When the antenna end is close to the ground in a sloper fashion, there could be even 6-fold loss of gain on the fundamental frequency. Horizontally polarized radiation is broadside. This is the signal at low angle and meant for long distance communication, but weak for a sloping antenna. Vertically polarized signal will be strong and primarily from the part of the antenna nearest to the ground and more suitable for short range contact by near vertical incidence skywave NVIS propagation. On second harmonic also, the gain can drop by 2/3 for a sloper mounting. So getting the antenna as high as possible and as straight as possible should be the best option. Grounding is another important aspect to be considered. When the 49:1 balance is mounted high up, if you run a grounding wire from there, it is likely to pick up electrostatic charge and is hence not recommended. If the balance box is near the ground, the grounding hook near the SO239 connector can be grounded using a short grounding wire. If the 49:1 balance is high above the ground, typically at 20 feet or more, instead of grounding the hook near the SO239, grounding of the coax shield just before it enters the shack is recommended. This will prevent RF on the shield from entering the shack and potential RF bites from metallic components and RF interference with sensitive equipment in the room. It is worthwhile remembering that in case of EFHW, the antenna as well as the coax shield radiates RF. A good quality common mode choke between the antenna tuner and the radio has also been recommended. But I do not have an external antenna tuner, only a built-in low-range antenna tuner within my FT710 radio with range of up to 3:1 SWR. With this background information, I decided to cut the length of wire of my EFHW into half so that instead of 40 to 10 meter, it will become 20 to 10 meter EFHW. As I already have a 40-10 meter combination inverted V dipole, I was just in need of a 20 meter antenna. In this video clip, you can see the original antenna with balance box having an SO239 connector and a grounding hook near it for use when it is mounted near the ground. An insulator is also seen. Here you can see that I have removed half of the antenna wire and kept it as a coil beside the remaining uncoiled part connected to the balance box. Then I took a 3 meter PVC pipe of 1¼ inch diameter, which I am planning to use as the first support, and tied the balance box firmly to a nut and bolt fitted at one end of the pipe. PL259 plug at the upper end of 10 meter of HLF 200 coaxial cable was connected to the SO239 connector on the balance box. After securely fixing the first support on the first floor parapet and the fence, the remaining part of HLF 200 cable was kept as a coil in hope of reducing the common mode current on the outer aspect of the shield, at least partly. Here is the final deployment of 10 meter long EFHW wire on available supports in the shape of an incomplete horizontal rectangle. You can see my Moxon Yagi for LEO satellite operations, CP22E VHF antenna, and part of 40-10 meter combination inverted V dipole near it. Wires of the two antennas have been kept nearly perpendicular to each other on most of its course, as that is all I can achieve on a small terrace with rest of the building having sloping roof with tiles. Apex of the 40-10 meter dipole can be seen to be several feet higher than the EFHW. SWR was 1.7:1 at lower end of 14 MHz band and 1.6:1 at upper end of the band. SWR at upper end came down to 1.1:1 after grounding the shield of the coax just outside the shack. SWR on 10 meter was 2.2 at lower end and 1.0 at 29 MHz. After grounding the coax shield, it changed to 2.5 and 1.1 respectively. So, grounding had a favorable effect on SWR at 14 MHz, while it had an unfavorable effect on 10 meter. The most crucial on-air testing will have to wait for appropriate band conditions on 20 meter and 10 meter band, and shall post it as an update later.